Trying to get a coffee in before the video started. Sorry about that. What do we have here? We have buffer problem, part 2. I grabbed one from the fall 21 exam. And it's got a tripeptide here. Pro-sear hit lice. You don't need to know what it looks like, even though on this exam it does show you. Sorry. Just write down the work as we do it, okay? Yeah, we don't have a copy of this. Yeah, on this piece of paper I gave you already. Exactly. It's got a lot of room in there, right? Okay, so put your name. You got your name on it already. This would be activity 2. We didn't. I know it was mislabeled as activity 2. This is activity 2. You got 2 activity 2s now. Okay, how many pKa's did I give you? 3. So the fully protonated acid has 3 protons because I gave you 3 pKa's. So a good generic formula for the fully protonated one, I'm going to do it on the test, and I strongly suggest you to do it like this. H3A is that one. What does it become after it loses a proton? I need the formula after that loses a proton. Yeah, you gotta be more careful with your charges. H2A, somebody said it, minus. You took away a proton. Please don't forget a proton has a plus charge. There we go. And I'm gonna take away a proton from that. And what do I have for the third species? Yes? Yes, he's recovered nicely. Good job. Okay, so in this one, you're told you're not starting with any of these. You're starting with the species that has had all of its protons removed. How do I know that? What word said that? Fully deprotonated. I'm sorry, it was 2 words, wasn't it? So give me the formula for the fully deprotonated form, the one that has 0 protons. No, 0 protons. You just gave me 3. A3 minus. I know what happened. Okay. A 3 minus or minus 3 is where you're starting. Your initial position is to start with A 3 minus or minus 3, whichever you prefer. And I stands for initial. C stands for change. Now, normally E stands for equilibrium, but here it's just N. We're only dealing with weak acids here. So whatever the math gives is what you have. Because a weak acid is not going to react further. A weak base is not going to react further. So how many moles of A minus 3 am I starting with? 3. I'm going to move my A minus 3 just a little bit. Uh-oh. Can I get the minus 3? Apparently not. Sigh. And you said 3. And what's it reacting with? What's the formula for hydrochloric acid? HCl. What happens to hydrochloric acid when it loses a proton? Because that's what's going to happen. Cl minus. What's it called? Chloride. Now, I'm going to write this here. It seems a little irreverent, but Cl minus never does anything in acid-base chemistry. So I wrote it here, but I didn't have to. That's why I'm writing who cares. It's not a player. It's like you made a spectator. Now it's just sitting around watching all day. The most important thing, though, is what happened to A minus 3. HA minus 2. And you started with none of that, right? HCl, how many moles did you start with? HCl. Okay, which one's limiting, the 3 or the 4.75? 3 is the most reaction you can have. All of it's going to react. So A minus 3 is no more. Not part of this story anymore. HCl still in the picture, right? How much? That means you're not finished. Your finished ice problems when your strong acid is used up, if you're using a strong acid, or if your strong base is used up. That's this morning we did a base one, hydroxide. We only use hydroxide as a strong base in this class, okay? So you know you're not done until your HCl is at 0 or your hydroxide's at 0 in the other problems where you're adding a base. There's your two scenarios. Okay? So we don't care about Cl minus anymore, but we started with 0 of this one. How much did we make? How much? 8. For every mole of A minus 3 that I react, I make a mole of HA minus 2. 1-to-1 stoichiometry. So when I react 3 moles of A minus 3, how much HA minus 2 do I make? 3. Ice number 2. You have HA minus 2. And you have 3 moles of it. You have HCl still. And you have 1.75 moles of it. You're making Cl minus, but I don't care. What are you also making? Remember, HCl gives things protons. That, and what's your charge? Minus. So we started with 0. Which one's limiting this time? HCl. You can only react 1.75. Aye. Oh. Yeah. No. Minus 1.75 for both. 0, 1.25. Plus how much here did you make? H2A minus, how much did you make? Correct. Here are the two species. Here you have a happy face. Why am I happy now? I'm done with the math, yeah. I'm done with the math because my strong acid's gone. Because I only reacted 1.75 HCl with 1.75 HA minus 2. That amount of reaction creates 1.75 moles of H2A minus. 141. And what do we got? We're happy because HCl is gone. Here's your two species that you have when you're finished. You have a mixture of H2A minus and HA minus 2. Question 1. Which one is the acid in this pair? Easiest question of the semester. You look at two species, they got the formulas written, the one with what, the extra proton or the one missing the protons, the acids? Extra proton, acids have protons. So answer is H2A minus. Can you tell me the pKa? We wrote it at the top of the screen. We had it. I don't know what happened there. Oh, cancel, man. What are you doing to me? I don't even know how to deal with this, everybody. I'm just going to minimize it. Are we still recording? Yes. My head's moving. I'm waving to myself. Okay. H2A minus, what's the pKa? We wrote 3. We circled the 3. Okay. 10 point who? 10.4. We wrote that right here, didn't we? The reason we did it is for now. So we can use it. We know this buffer is good at keeping pH close to 10.4. That's what buffers do. Keep pH close to what? It's only the most important thing. What do buffers keep pH close to? What do they keep pH close to? pKa of the acid in the buffer, right? Yeah. And this, you just told me this is the acid in the buffer. We already know, we were told by the teacher, the pKa of this is 10.4. You will not have to memorize pKa's for these problems. So, your answer is close to 10.4, I promise. You don't need the equation, but I'm just going to remind you what it looks like. pH equals pKa What goes on the top again? Base or acid? Base should go on top because bases raise pH. Acid should go on the bottom. Acid lower pH. I've got a little more of which species. I know it's confusing because there's only one H here, and now we've got two. Guys, this is the generic for acid and its conjugate base. You can't screw this up. That has to be the acid. The other one doesn't even have a proton, right? So in this pair, this represents the acid, which is the denominator, and the numerator is the base, which is here. Which number is greater? Acid or base? You don't even need the equation. You said the acid's greater. pH is close to 10.4, but down. Acid than base. Therefore, pH equals 10.4 with a down arrow. Now, in the multiple choice, I can guarantee if it was a multiple choice question, that would be the choice. That's how effective buffers are at keeping pH close to pKa. It's only 0.1 below, right? Why below again? Remind me why it's below and not above. Because we have more acid than base. If I had, you know, pKa of 10.4 and these numbers were reversed, I'd say the answer is 10.5. Yeah, if these numbers were reversed at 0.7, 1.25 and 1.75. What would happen if the numbers were exactly equal? 10.4 is the answer. It's called a perfect buffer. Ideal buffer is another way to say it. Equal amounts of acid and conjugate base, both partners weak. Weak. All right, so we did that one. We good? There we go. Guaranteed test question.